Welcome back to the continuation segment, and we're going to continue talking about the trigonometric functions of the angle theta with respect to sine t, cosine t, tangent t, cosecant t, secant t, and also cotangent t. Now, let's look at this. Sine theta is equal to sine t. Cosine theta is equal to cosine t. Tangent theta is equal to tangent t. Cosecant theta is equal to cosecant t. Secant theta is equal to secant t. And cotangent theta is equal to cotangent t. Now, if you remember, when you used to punch in your calculator what the sine of 90 degrees was, if you look on the graph of the unit circle, of course, sine pi over 2, which is sine of 90 degrees, this is in radius, and of course it's in degrees, you notice that 0 and 1, that's the point there that you see, 0 and 1. So sine, which is the actual y component of the point, is going to be 1. So sine 90 will equal to 1. And also cosine 90, which is the x component of the point, is going to be 0. So cosine 90, cosine pi over 2, which is cosine 90, will equal to 0. And we'll talk more about that later on. We're going to talk about the unit circle in depth in later videos to come. For right now, let's go ahead and let's do a problem. First of all, before we go to the problem, let's talk about the theorem here. For an angle theta in standard position, let the point P, which is on any point on the terminal side of theta, that is also on the what? The unit circle, x squared plus y squared is equal to r squared. Then this is what you have here. This looks very familiar, doesn't it? Sine theta is equal to b over r. Cosine theta is equal to a over r. Tangent theta is equal to what? B over a. This will be the opposite side over the hypotenuse, the adjacent side over the hypotenuse, and also the opposite side over the adjacent side. Of course, these are your what? Your infamous what? These are your reciprocal identities. So you see this. So remember though, in each of these, there's a restriction. A can't equal to 0. B can't equal to 0 for cosecant. Of course, A can't equal to 0 for secant, trigonometric function. And B can't equal to 0 for the cotangent trigonometric function. So if that happens, results in a 0, then that will cause these functions to become undefined. So let's look at the angle. Let's look at the unit circle here, and let's look at these unit circles. However, let's look at the what? Let's look at the angle. 45. Now this point right here, as you see, this is AB. This is the point that's represented on the unit circle here. And if you see that, this is going to be A, represented the A side, and this is also what the B side. Now, with that in mind, when we say the sine of 45 degrees, right, the sine of 45 degrees, we're going to do some calculations here, and we see that we come up with 2 over 2. So in actuality, we will put the point here on here of trigonometric function will be, for the A, it'll be the square root of 2 over 2, and also for the sine value, it'll be also square root of 2 over 2, as you see right here. This will actually be placed onto the unit circle once the unit circle is fully developed. But these 2 points right here, 1 and 1, are represented by P. P is equal to AB. So this is the A, and this is the B. So let's go to the angle here. The angle 30 degrees, of course, we have the side here, the opposite side being 1, and then the adjacent side here is going to be the square root of 3. Now, the point that corresponds to the angle, of course, just like the other one we did previously, 30 degrees is equal to the square root of 3 and, of course, 1. Now, the sine of 30 is going to equal to 1/2, and the cosine of 30 is going to be equal to the square root of 3/2. So this actually will go right here at this point on the unit circle as the actual trigonometric function of values for these. Like I said before, we're only talking about the points here, but when we actually build the unit circle, we'll actually take the trigonometric function values and place them here at these points. Let's talk about the angle 60. The angle 60, of course, you got the point AB, this is 1, and this is also the square root of 3. And when you have the sine of 60 and the cosine of 60, here for the sine of 60, you have the square root of 3/2. And also for cosine 60, you have 1/2. And so actually, these will go right up here, and it will be replaced these points because these are the trigonometric functions. These here are just the points, and which are identified on the unit circle. Now let's do a problem. We're going to do a problem here. There's a point on the terminal side. Now, look at this graph here, and let's look at the solution. And we're listing down what is given. The point 4 and -3 is on the circle, as we see. And we want to put this into the formula, the Pythagorean theorem, so we can find what the radius is, or we can say we actually drew a triangle, that'll be the hypotenuse, wouldn't it? So we found R to be equal to 5. And for the points A and B, A representing 4 and B is being represented by -3, and of course R being 5. So actually you're going to set these up into the trigonometric function, and here you get your exact values. Here as follows: -3/5 for sine theta, cosine theta 4/5, tangent theta will be -3/4, and for cosecant theta it will be -5/3, secant theta will be 5/4, and also cotangent theta will be -4/3. This is how you will find the exact value of each of the 6 trigonometric functions of an angle when given a point on the terminal side. Now let's talk a little bit about the domain and range. It is very important that we talk about the domain and range of trigonometric functions. So let theta be a standard position, and let P be some point on the unit circle that represents or corresponds to what? To theta. Look at this here. This is our unit circle. And we know that sine theta is equal to B, cosine theta is equal to A, tangent theta is equal to B/A. Now remember, A can't equal to 0 for that one. And for cosecant, right, it's 1/B, which B can't equal to 0. Secant theta is equal to 1/A, in which A cannot equal to 0. And then cotangent theta is equal to what? A/B, in which B cannot equal to 0. Now, understand this, that the domain of a sine function is the set of all real numbers. And the domain of a cosine function is also the set of all real numbers. Now, for tangent and secant functions, the x-coordinates of P, of the point, cannot be what? Cannot be 0. Since the result in division by 0 will cause that to be what? Y'all remember? This cannot be divided by 0 because that will cause that to be undefined. So for tangent and secant, right? Particularly for tangent and secant, these A can become 0. I know I put the cotangent, if this was dealing with cotangent, also here, B can't be 0 either. But now for this particular situation when we talk about tangent and secant functions here, you know that A cannot equal to 0 because that causes that to be undefined. Now, on the unit circle, and I'll explain this, there are 2 points, right, on the unit circle here. There's 0, 1, and then you got 0 and -1. Those points correspond to both, pi/2 in radians and in degrees it's 90 degrees, such as we have had plus or minus pi over 2 or plus or minus 90 degrees, or if you have plus or minus 3 pi over 2, which is what? 270 degrees, and also plus or minus 5 pi over 4, which is 450 degrees. Such angles must be excluded totally from the domain of the tangent function and the secant function, because those things will become totally inexistent. Now, follow me and let's go to the other functions here, if we will. And as you notice here, the domain of the tangent function is a set of all real numbers except what? Odd integers, which are multiples of what? Pi over 2. And also in degrees, 90 degrees. And the domain of the secant function is a set of all real numbers except odd integers, which are multiples of pi over 2 in radians and also degrees, 90 degrees. Now for cosecant and cotangent functions, the y coordinate of the point A and B, it cannot be 0, since this will result in a division by 0, which will cause this to be an inexistent or undefined function. And on the unit circles, two such points such as -1 and 0 and 1 and 0 corresponds to the angle 0 degrees and also pi or 180 degrees. However, going into more detail, multiplying pi and 0 and also, well, pi on 180 degrees or 0 and plus or minus pi or plus or minus 180 degrees or plus or minus 2 pi plus or minus 360 degrees and plus or minus 3 pi or plus or minus 540 degrees. Such angles must be excluded from the domain of what? Cotangent function and the cosecant function. Now, we talked about the domains of these functions. Let's discuss cotangent. The domain of a cotangent function is a set of all real numbers except integers which are multiples of pi, 180 degrees. The domain of a cosecant function is a set of all real numbers except integers or multiple of what? Pi or 180 degrees. Now let's look at the range of these things. Let's look at the range. Let P equal to AB, some point on the unit circle that corresponds to the angle theta, and it follows that -1 less than or equal to A less than or equal to 1, and -1 less than or equal to B less than or equal to what? 1. And since sine theta is equal to B and cosine theta is equal to A, we have -1 less than or equal to sine theta less than or equal to 1, and -1 less than or equal to cosine theta less than or equal to 1. For cosecant, we have cosecant theta less than or equal to -1, or cosecant theta greater than or equal to 1. And of course we got secant theta less than or equal to -1, or secant theta greater than or equal to 1. Now, for tangent we have negative infinity, right? Less than tangent theta, less than positive infinity. And for cotangent, we have negative infinity, less than cotangent theta, less than positive infinity. Now, let's go over, let me show you a chart, which basically summarizes everything here a little bit easier. So let's look at this, and just look at the chart, and you can read this is pretty much self-explanatory. For sine, and this is the symbol, f of theta is equal to sine theta. Domain will be all real numbers, and here the range is all real numbers from -1 to 1, inclusive, right? For cosine, the domain is all real numbers from -1 to 1. It's also inclusive. How about tangent? For tangent theta, the domain is all real numbers except odd integers, multiples of what? the radians of pi over 2, which represent 90 degrees. And these are all, for the range, it'll be all real numbers. And if you look at cosecant theta, it's all real numbers except integers, multiples of what? Pi, which is in radians, and 180 degrees. And the range will be all real numbers greater than or equal to 1 or less than or equal to -1. And as we continue on, for secant theta, it's all numbers except odd integers, multiples of radians pi over 2, and the degrees will be 90 degrees. And also, for the range, will be what? All real numbers greater than or equal to 1 or less than or equal to -1. And lastly, cotangent will be all real numbers except integers, right? Multiples of what? Pi, and also 180 degrees. And for the range, it'll be all real numbers. Now, I know this was a little bit much, so if you will, just go back, pause the tape, rewind, and get the notes. Try to copy down, go back, and try to ingest all the knowledge that was presented to you. And we will talk about the unit circle in detail and more in depth. We'll probably try to construct it, showing you how each of the numbers are developed in the unit circle. And looking forward to seeing you really soon. Daniel Fritz Mathematics. So long.